Think math.
Here is a pair of equations. X plus y equals 3, and x squared plus y squared equals 5. Meet a pair like this, and you do what you were taught. Take one equation and substitute it into the other. But why substitution of all things? Why go to the trouble of wiping out one of the letters? The reason lives in the graphs. Take just one equation on its own. The pairs that satisfy the first one are not few. There are endlessly many, and collecting them all traces out a straight line. The second equation behaves the same way, and collecting its pairs traces out a circle. A pair that satisfies both at once must lie on the line and on the circle at the same time, so the answer is where the two graphs cross, right here in two places. Let us find those coordinates by hand. The trouble is that there are two letters, and the only equations we know how to solve carry one, so we peel off the simpler equation. Y equals 3 minus x. Drop that into the y of the other equation, and it becomes x squared plus, bracket, 3 minus x, bracket squared equals 5. Tidy that up, and it reads x squared minus 3x plus 2 equals 0. One letter left. Substitution was a tool for erasing a letter. Factor it, and x is 1 or 2. Do not stop there, though. What we were after was a coordinate, a pair, so substitute back. When x is 1, y is 2. When x is 2, y is 1. And here's the trap to avoid. You may not take the two values of x and the two values of y and pair them up freely into 4 answers. The pairing is decided by the equation you substituted. There are 2 answers, and they are exactly the 2 crossings we saw on the graph. What if both equations are quadratic? Say x squared minus y squared equals 0, together with x squared plus y squared equals 8. There's no simple equation to peel y from, but the first one factors. Bracket x minus y, bracket times bracket x plus y, bracket equals 0. For a product to be 0, y must equal x or y must equal minus x. 2 simple equations have appeared out of nothing. Feed each of them in, and x squared comes to 4, so x is plus or minus 2. 4 answers this time. Substitution is not a trick. It is the road back to an equation you already know. A sip of math every day, here at Think Math.